Hello, this is Charlene. We are going to be talking about the cardinality of a set. The cardinality of a set essentially is just the number of distinct elements in a set. And this word distinct is important because it basically means that they do not care about duplicates. No duplicates are counted, only unique, distinct elements. And we also have a bit of information here at the bottom. It's talking about the empty set. If A is the empty set, it has 0 elements. So the empty set, of course, can be um, designated with the null symbol, or it can be designated with a set of brackets with nothing in it. So that's the null set or the empty set, and that has a cardinality of 0. So the way that we notate it is with this notation N of A, but we read it cardinality of set A. So, but the N definitely just stands for the number of elements, unique elements in set A, or the number of elements in set B. But we pronounce it or say it the cardinality of set A. Okay. So our first question down here wants to know cardinal number. And we want the cardinal number that also is the same thing as saying what is the cardinality of the set. We have that set A is equal to A, B, C, Z. And so is the ellipsis, and it just means that the list is going to continue as it starts. So ABC means all the ABCs, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, et cetera, until we get to the letter Z. So if you know how many letters are in the alphabet, you do know that there are 26 elements in this set. So we would say the cardinality of set A is equal to 26. Okay. So our next question says that set B is a list. This is the roster format for expressing a set. It's a list. So a list of numbers. This list includes 6, 10, 14, 15, 16. There are no duplicates, so we don't have to worry about anything. We don't have to mark anything out. And there are 1, 2, 3, 4, 5 numbers. So we would say that the cardinality of set B is equal to 5. Our next one says that set C is equal to the set, which is notated by the roster format, of the numbers 11, 12, 13, which is our ellipsis, 22, 23. So it starts with number 11 and it goes to number 23. And we want to ask ourselves, how many numbers is that in that set? Well, we might be tempted to say, okay, what's 23 minus 11? Well, 23 minus 11 is actually equal to 12. However, when we do that, it actually does not include the last number. It does not include the 23 because if we look at all these numbers, um, kind of spread them out and count them, we see I've got number 11. Let's see here, right here. Number 11 starts right here up to 23. When I count them, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I actually have 13 numbers. So that means that all of this set, the cardinality of set C is equal to 13 because there are 13 numbers in that set. Our next problem or question asks us to tell them the cardinality of set D. Set D is equal to the set containing the number 0. So there is literally 0 is a number, so it's literally just 1. The cardinality of set D is equal to 1. Okay? And the next one is what we talked about at the beginning. The fact that this is the empty set. When we have a set of brackets with nothing in it, that is referred to the empty set. So the cardinality of set E here is equal to 0 because there are no elements in it. It literally is an empty set and there are 0 elements. Okay. Now we have set F. Set F, this is the set builder notation for a set builder notation. So it says that X, such that X is a letter in the word vowel. Okay, so it's talking about the letters that are in the word vowel. V, O, W-E-L. And of course, we just want to make sure that we do not have any duplicates, and we do not. V-O-W-E-L are all unique or distinct letters. There are no duplicates. So we're going to count all the letters. So 1, 2, 3, 4, and 5. So that means that the cardinality of set F is equal to 5. Okay, then now we have set G. And it's also in the set builder notation for describing a set. So it says that X, such that X is an element of the natural numbers and it is between 3 and 7. So that's what that means right here. This little piece right here, when X is in the middle, it means it is between 3 and 7. It also says equal to. So it's including 3 and 7. So that means it's a natural number. Natural numbers are counting numbers, which means it would just start with 1. But it's also restricted by this right here. So that means it's equal to 3. So that means it would include 3. And it would be 4 and then 5, and then 6, and then 7, and it says it's equal to 7, so it includes 7. So that means we have 1, 2, 3, 4, 5 elements. These numbers 3, 4, 5, and 7 are also natural numbers, so that restriction is met as well. So that means the cardinality of set G is equal to 5. Our next question says that H is equal to the set of 872. Now, this is definitely just one number. It's not 3 digits. If it was 3 digits, they would have commas between them. So it is just one number that is in the set. So the cardinality of the set of H is equal to 1. Okay. We also have another problem here. The set of I is equal to Zambia, Colombia, Poland, Italy, and the US. So we just want to always make sure that we do not have duplicates. We do not have any duplicate countries. So therefore, we count each of those 1, 2, 3, 4, and 5. So the cardinality of set I is equal to 5. Now we have set W is the set of days of the week that begin with the letter T. And of course, this set is just defined by words, by a sentence. So the set of days that begin with the letter T, let's see, that would be Tuesday, and Thursday, right? Tuesday and Thursday. I think that's the only days that begin with the T. So that means that the cardinality of set W is equal to 2. Now we have set M. It's the set of months that begin with the letter M. Well, we're going to have to think about this one. January, February, March, right? March, April, May, June, July, August, September, October, November, and December. So There are only 2 months that begin with the letter M, so the cardinality of the set M is equal to 2. Now we have set K. Set K is equal to the null set. And like we spoke about before, the null set and the empty set are the same thing, and they both contain 0 elements. So the cardinality of set K is equal to 0. Now we have the set S is equal to the word 7. So the word 7, it is just a single word. So the cardinality of the set S is equal to 1. Now we have the set of P. It is equal to X such that X is a letter in the word 7. Okay, so this is different from the one that we just did. We actually did a set that was contained just the word 7. This one is describing the letters in the word 7. So that means we need to look at the letter S, the letter E, the letter V, oops, the letter V, and the letter E, and the letter N. Now, again, we need to be careful and make sure that we do not have any duplicates. Oops, let's go ahead and pull that back down there. Okay, so do we have any duplicates? Because cardinality does not include duplicates. So right there, I have an E and an E, so that is a duplicate. I'm not going to count that second E. The unique and distinct letters are S, E, V, and N. So that's 1, 2, 3, and 4 unique letters. So the cardinality of set P is equal to 4. Now we have set Q. Set Q is equal to X such that X is an element of the natural numbers. So it means it's going to start with the number 1. It will not include any negative numbers or 0. And it says, and the numbers are less than 5. So again, because we're starting with natural numbers, we're starting with 1, and then we would also include 2, 3, 4, and maybe 5. But it says it's less than 5. So it does not say that it's equal to 5. So therefore, it's less than 5. So we do not include the 5. So that means I have 1, 2, 3, 4 elements, which will be included in the set Q. So that means that the cardinality of set Q is equal to 4 elements. I have one last problem to do. The set of Y. The set of Y is equal to the set of X such that X is a month that ends with the letters BER. Okay, so which months end with BER? January, February, March, April, May, June, July, August, September, September, October, September, October, November, and December. So there are 4 months that end with "ber": September, October, November, and December. So the cardinality of set Y is equal to 4. So that's the end of this section. And we hope you come back real soon. Click on that subscribe button, click on the like button, and we'll see you for the next video.